All right, next up, this concept's not too bad. Probably heard of it before, maybe freshman year, sophomore year. Chemical change, physical change. So a chemical change is where you change the chemical composition. Okay? Another word for composition, the chemical formula, the chemical identity, the chemical structure, all right? Any of those words work, think chemical formula. All right? All of those things work. You change the chemical composition, there's new substances with new properties, okay? After a chemical change, there's completely new properties. If you have something that's magnetic, afterwards it might not be magnetic. Before, maybe it's a good conductor of electricity, afterwards, maybe not. Physical change is just the opposite. There's no change in the chemical structure, okay? So, think, tearing a piece of paper. Even if you have a piece of paper and you tear it in two, it's still a piece of paper, all right? Its size changed, yes, and it's got maybe a jagged edge now, but it's still flammable, it's still the same color, it's still all those same things. So physical changes, smashing, breaking, tearing, sharpening, cutting, just anything where it's still the same substance. Chemical change, think, for example, burning, okay? If you burn something, you have a new substance. Think of rusting or oxidation, okay? You have an iron nail, it rusts, it's now iron oxide, it's a new substance. It might be much more fragile and easier to break, and it's not as, not as strong. One thing to know with physical changes, and this is what's tricky, phase changes are physical changes, which includes boiling, melting, freezing, etc. All those things. Okay. You think boiling or melting? Oh, it's a new substance. It's really not. If you have, water or ice, it's still H2O. If you melt it or freeze it, it's still H2O. You didn't change its chemical structure. It's still H2O. That's probably the tricky part right there. Is phase changes are physical changes, whereas burning, rust, baking food, digesting food.